Oh my goodness. I passed out a warm-up, right? So this is the section 6.1 warm-up on my classes. And we have a couple of angles here, okay? I think we went a little bit fast last class with the angles, so I just want to make sure everyone's pretty good on this. So let's see. How about this? I'm going to do 2 of these on the board without looking at myself on the screen. And then I'll let you guys on your own for the rest. So let's just take a look at number 1 on the front page, by the way. This is telling us to draw the angle approximately 147 degrees. Okay, so when we're about to do this, there are 4 kind of like reference points here on our graph, right? We've got 0 degrees, 90, 180, and 270, right? A coterminal angle for 0 is 360. Oh, yes, 360 degrees in a circle, right? Okay. So is 147 going to be in quadrant 1, 2, 3, or 4? 2, right? It's going to be between 90 and 180. So I'm just approximating this here, but I think 147 is going to be, I don't know, like here, right? Now we're not done yet. Is the angle going to be going counterclockwise or clockwise? Counterclockwise, right? Counterclockwise represent positive angles, clockwise represent negative angles. So I'm going to start from the initial side and draw a little circle pointing the counterclockwise direction. Okay. Let me just skip over to number 3. It says negative 32. There's 2 methods to think about negative angles. Okay. Now, if we're going the negative direction, we're going the clockwise direction. So technically, I can think of us going from 0 to negative 90, right? To negative 180, all the way up to negative 270. Okay. You can think of it here and try to draw your angle this way. I think a better method in my head is to find the coterminal angle. Okay. So coterminal angles, how do we find those? Yeah, add and subtract 360. Good. Since this is negative and I want to probably find a positive one, let's add 360 to negative 32. Anyone know what negative 32 plus 360 is? I'm not very good at adding stuff in my head. 328, good. Okay, so using this method, I don't have to think about the negative angles, but 328, let's see. It's not between 0 and 90. It's not between 90 and 180. It's not between 180 and 270. It's definitely between 270 and 360, right? So it's probably going to be somewhere here. Okay. And is my angle going to go counterclockwise or clockwise?
Clockwise.
Clockwise, right? Clockwise are negative angles. So I'm going to start at 0 and go clockwise until I hit this one. Okay. Any questions on these 2? All right, why don't you try the rest of these? I think this will get us on the right track for the rest of the notes. Right here. Okay, so we did number 1. Number 2, was that Sam?
Yeah.
Okay, Sam, do you kind of want to explain how we got this one?
Yeah, so since it's 289, I went to the quadrant that's a little bit after 270, and I just kind of estimated where I think that would be in that quadrant. And then since it's positive, just draw like a really large circle kind of thing to get all the way to 289.
Awesome job. Any questions on number 2? Picture this. All right. Sorry, Stephen, if you can't see this. Maybe you can. I don't know. All right. Number 4. Who is number 4? Wait a second. All right. Do you want to explain how you got this one?
Yeah, I just did what we did for
and I just did like a -8, 189. So it's 9.5.
Awesome job. Another method you could have used for this is to find the coterminal angle, right? You could have took 189 and added 360, and that would have gotten you, oh my gosh, 171, right? Okay, so this angle is the same as positive 171, but you'd still draw the angle the clockwise direction. Okay. Any questions on number 4? All right. Take pictures of number 4. All right, number 5. Was that me?
Yeah,
Yeah.
well, for negative, I just think of everything backwards.
Mhm.
So you start from one line and just go backwards, so the coterminal angle. The 270 is now 90, it's negative, so you just go 2 past.
Awesome job. Any questions on number 5? You did do a really good job. I'm very proud of everyone. All right, number 6. Forget who that was. Sorry. Oh, you should know, right?
Yeah.
You're waiting for me to figure it out, were you? All right, do you want to take us through this one?
So, since it's like the smallest number, I assume that like, since like in 30 degrees, it's like trying like the smallest one you can do. I just made mine a little small.
Nice job, nice. So yeah, it was like, I like how you even realized that 30 degrees is here, and it was like 30 degrees is kind of up here, so 12 degrees is even smaller than that. So really nice job on that one. All right, take a picture of that. All right, any questions on the front page of the warm-up yet, or so far? Okay, we probably won't get to the back page of the warm-up, so make sure you save this for Monday, okay? But how about this? We are going to continue our notes from last time. So section 6.1, we dealt with angles, and we've been dealing with these things called degrees, and we're pretty good with graphing them. And we're pretty good with looking at angles in terms of like the standard position. All that means is we have an X and Y axis and we drew the angle on top of it, right? Okay. We know that an angle is positive if it's counterclockwise and it's negative if it's clockwise. And we did a few examples with that. We know how to find these things called coterminal angles. That's the stuff that's going to be on the quiz, right? And these things are just different ways of representing an angle. And there's not just 2 coterminal angles for any angle. There's multiple, right? We can add 360 how many times we like. We can also subtract 360 a bunch of times. And we have different names for the same sort of picture on the board. Okay. All right. I think we left off on this thing called the unit circle. And I think people are kind of scared of this, but all it is a circle of radius 1, okay, and it's on the graph, okay? So we didn't go through everything on the unit circle. We're kind of gonna baby step through this so we don't get thrown a bunch of stuff all at once, okay? But we did talk about some important angles here, okay? I think the most important angles on the unit circle are the 0, the 90, the 180, 270, okay? And then these 3 angles here, 30, 45, 60, right? These are the important ones that you probably will have to memorize, okay? Now, if you don't feel like memorizing, there are some ways to kind of remember what these angles are. So if this is 0 and 90, the 30 and 60 cut this into thirds, kind of like a pizza, right? So if you kind of ignore that 45-degree mark, the 30 and 60 are dividing that 90-degree angle into thirds. So 30, 60, 90, just adding 30 to 0 a bunch of times, okay? The 45 is cutting the 90-degree angle in half, right? So 45 is half of 90, okay? Now, I do require you to know all the other degrees on the circle, but there is kind of a catch. You don't have to memorize these because we figured out how to get to them. So does anyone remember how we got to like the angle 120?
You add 30 to 90.
Yeah, we added 30 to 90, good. And then we got 135 by adding 45 to 90. And we got 150 by adding 60 to 90, right? Okay, let's just continue this. How would I find this angle? Good, right? We're starting at 180 and we know we have to go a little further and we know that amount is 30 degrees. So we're going to take 30 plus 180 and that is going to give me, I'm very bad at position here. Let me pull this up in my notes. I don't write something wrong. 210 degrees. How would I get the next angle coming up after it? 180 plus 45, good. So 180 plus 45 is 225 degrees. And how would I get the last degree on the third quadrant there? Awesome, 180 plus 60. Okay, so this would be 240. Okay. So you don't actually have to memorize them. You do have to know what these are, but you can just find what they are by adding and subtracting. Okay, I'm going to give you like a minute to find the last three angles, and then we'll make sure that we have the right numbers written down. Good. All right, I think everyone's got the right numbers written down here. What were the three numbers? 300. And awesome. Okay, so I think we're all pretty comfortable at identifying the angles on the unit circle. You really only have to memorize maybe the 0, 90, 180, and 270. Might want to memorize 30, 45, 60, and then everything else you can just calculate by hand once you know those angles. Okay. Any questions on the unit circle so far? Okay. So I think we feel pretty comfortable with identifying angles with the degrees, trying to draw them, approximating what they look like, finding them on the unit circle, finding coterminal angles. We're going to kind of bring this up a notch, okay? All right, so I think so far all we've been doing is dealing with angles using these things called degrees, right? Like 30 degrees, 60 degrees, 90 degrees. Anyone know why we use degrees like as a American society? Yeah. Wait, what? To torture us, yeah. I think degrees are a little bit easier to use than what we're getting to, but all right, there's actually two reasons. I actually got this idea from this YouTuber named Eddie Wu. He's really a cool guy. But he gave two reasons why Americans and a lot of other like places use degrees normally, okay? So historically, degrees have been used by Babylonians, okay? They were kind of, I don't know if they were the first people to use them or not, but they used a different number system than we use today. Today we use what's called a base 10 number system. It's basically how we count, right? We have 10 fingers, 10 toes. We count money in tens, right? We have $10 bills, $100 bills, pennies that go from 0 to 100, right? So we use what's called a base 10 number system. Things are multiples and degrees of 10. Okay, Babylonians used degree 60, not because they had 60 fingers or anything, but because 60 and 360 is a pretty good number to work with. And I'll explain why. Okay, so 360 is a very interesting number. Okay, and let me just write this. 360 is a very interesting number because, well, it's even, right? So it's divisible by 2, right? Is 360 divisible by 3? Yeah, right. I think the digits are 3 and 6. They add up to 9. So it is divisible by 3. Don't believe me, type in your calculator. Okay. 360 is divisible by 4, right? 36 is divisible by 4. So 360 is 2. Okay. The last digit is a 0, so it's divisible by 5. You can check this in your calculator. It's also divisible by 6. Okay. Not divisible by 7. okay? Divisible by 8, 9, 10. I don't know if it's divisible by 11. Let me just check. What's 360 divided by 11? No, but it is divisible by 12, right? So 360 is very easily factorizable, right? You can divide it by pretty much all of the single digit numbers. And as you increase the factor, it divides a lot more, okay? So this is really easy to work with. It's a very useful number because it factors very easily. We can split it up into many different whole numbers. Okay. Here's the second reason why 360 is such a good number to work with and why we use 360 degrees in a circle. And the reason of this is sailors. Okay, that kind of sounds a little weird, right? What do sailors have to do with circles and 360 degrees? Okay, let me give you a scenario here. When you're driving somewhere, like you're driving somewhere that you don't know, you usually type in the address into your GPS, right? And the GPS will tell you like, turn at that sign, or turn at the exit, or turn at the food mart, or something like that, right? So they're landmarks normally when you drive around to figure out where you're going, okay? Imagine you're a sailor out in the open sea, right? So you're just out in the open on your sailboat and there's no landmarks. How do you figure out where you are? A compass, good. And your coordinates, and how did those, ooh, the stars, right? So yes, compass, coordinates, good, but those coordinates and, well, where you're going, the direction, are determined by the stars, right? So sailors would look up on the sky and they would look at the constellations, and that would kind of show them where to go, right? So going way back in time here. Okay. Now let me give you a scenario where sailors kind of got confused, okay? So I'm going to draw you a little picture. Here's the sun, okay? And let me just draw a very bad drawing of the earth. Okay, so here's the sun and the earth. Let's just say it's night and you're a sailor out in the open sea. You're looking up at the stars. What side are you on of this picture? Are you going to be on the right side of the earth or the left side? If it's nighttime, the right, because, well, if you're on the left, you'd be like, the sun would be above you. So you would be like looking up that way at the sky, right? All right, let's go in time. Let's say 3 months later, you're also looking at the night sky, and well, the earth revolves around the sun in a oval shape, right? So 3 months later, you're probably going to be here, right? Okay. Now, if you're looking up at the night sky, well, you're going to be looking that way, right? Away from the sun. You're going to be looking at a completely different set of stars up in the sky as you did before, right? So the view is going to change, okay? So Sailor has been doing this for multiple times. They realize that the stars kind of change, but they realize that about every 360 days, they got back to the same set of stars, right? So a year later, you went around the sun and you're back to where you started, and the stars came about again, okay? So sailors kind of realize that we are revolving around the sun, right? Or something weird is happening that has to do with 360 degrees. And that's why sailors use 360, okay? So convenience happened. Historically, things happen with the number 360. And this is kind of why we have 360 to represent a full revolution of things. So anything that involves a circle, we usually use 0 to 360 or degrees. Okay. Now, if we lived on a different planet, or if we were like somehow set away from the sun a little bit, we would just be using a different number system, right? We would be using 500 days in a year, or 70 days in a year, or something like that, right? So the thing about 360 and degrees is, well, there's really nothing mathematical about 360 or any degree that makes it better to use than any other number system, right? It's not really the best way to do things. It's just what we've been doing for a really long time, okay? So what's the alternative? Well, we have degrees and we also have these things called radians, which are inherently mathematical, by the way, okay? Before we go into what radians are, I'm gonna kind of tell you how most people think about radians, okay? Radians are the thing in your calculator that you have to switch to on the mode, okay? Now you all have different calculators if I'm looking around here. So what I want you to do is sometime between now and when we start dealing with trigonometric functions, I want you to look at your calculator. I want you to go to youtube.com, type in degrees to radians calculator in the search bar, okay? What you're gonna do is you're gonna look through all the videos and you're going to find a calculator that looks like your calculator, and then you're going to watch that video. Oh, you
I have this one on to do hit mode and it comes up with-
Oh. Awesome. So, okay, if you have a TIA board calculator, just hit the screen. Just hit the mode button at the very top, okay? And the very third thing on there says radian and degree. You're gonna want to change it to radians. Okay, because that's what we're going to be dealing with in the future. If you have a different calculator, just talk to me after class, or if you're struggling with changing it, just do that. Okay. But in this class, we are only going to be dealing with these things called radians. We're not going to really deal with degrees anymore. Okay. So now we know about radians. We know that they're the weird thing in your calculator that you have to change to radian mode. And that's pretty much all you know about radians so far. But let me just kind of explain to you what these actually are. Okay. Radians are a measure of angles that are defined by circles. Okay. And let me try to explain this a little bit better. Okay. Let me draw the standard position, right? And I'm going to draw the unit circle on it. So I'm just drawing the unit circle. Remember, the unit circle is a circle that has radius 1. That's all it's doing. Okay, so we know that like this point here is 1, 0. Okay. So what I'm going to do is I'm going to write something. Circumference. Anyone remember what circumference means?
The outside of something?
Yeah, it's like the perimeter or the outside of a circle. It's kind of like the length of the circle. Unfortunately, you can't like take a ruler and measure like the length around a circle. But if you took a string and like trace the outside of the circle, and then you took the string off and like stretched it out really long, the circumference would be how long that piece of string is, right? Okay, so circumference is the perimeter or like length of the circle. Anyone know the formula how to find that? Close. Pi r squared is the area. No squares. Okay, the way I remember this is we have two formulas for circles. One of them is the area, one of them is the circumference. The one that you have to square is the area because it's area square area. Okay. The other one doesn't have a square. Close. 360 is the degrees. Circumference is 2 pi r. That's the equation. Oh, did you say that? Oh, sorry.
Wait, what does R stand for, radius?
The radius, yes. Okay. Okay, so circumference, 2 pi r, area is pi r squared, area square area. That's the thing I always say to myself. Anyway, so on the unit circle, the radius is 1. So what's the circumference of the unit circle? If the radius is 1. Yeah, 2 pi times 1, right? So 2 pi or double pi. Okay. So the circumference of the circle, or like the length of the circle of the unit a circle is just 2 pi. Okay, so this is the mathematical definition of what a radius is. It's a lot more mathematical than degrees, which is just how many days there might be in a year. It's not even like the actual number of days in a year, so that's kind of lame. But there are not 360, but 2 pi radians in a full circle. Okay, so whenever I talk about radians, it's not that scary. I know there's pi in it, which makes it a little scary, but it's literally the same thing as degrees. But instead of going from 0 to 360, we're going from 0 to 2 pi. Okay, so 2 pi radians in a whole circle. Okay, so before we do anything too crazy with radians, I think we should talk about the 4 important radian angles, just like 0, 90, 180, and 270. Okay. So let's just say we have the angle right here, and I don't know, we're going all the way around the circle. Well, all the way around is 2 pi, 2 pi degree, or sorry, 2 pi radians in a circle. Okay. We can also look at that standard degree or standard position as 0, right? Just how we have 0 and 360. Now we have 0 and 2 pi. Okay, so if a whole revolution around the circle is 2 pi, what do you think halfway around the circle is? Just pi, right? It's half of the 2 pi. Okay, so this angle here from 0 to the other side of the x-axis is just pi. Any questions so far? Okay. All right, what do you think a 90-degree angle will be?
Oh,
Yeah, half pi or pi over 2, right? We normally write this as pi over 2, but if you want to read it as half pi, no issue here. Okay, so we've got pi, 2 pi, 0, pi over 2. What about the equivalent of like 270 degrees?
So one half pi.
I think I heard 3 pi before. You're very close, but the denominator is off. 3 pi over 2, right? So remember, a 90-degree angle is pi over 2. To get to the 180 degree, we're adding another pi over 2. To get to the 270 degree, we're adding another pi over 2, right? So it's 3 pi over 2. I wasn't really sure. I don't remember what you were saying, Shanor. I'm sorry, I was speaking over you. Okay, but this is 3 pi over 2. Okay, so things I want you to remember by the next class. I want you to review your notes before next class. I want you to make sure you know that we have 0 to pi, pi over 2, pi, and 3 pi over 2. That is the one job you have over the break, or sorry, over the weekend, for you to memorize these guys. Make sure you know these. These are the more important ones that you have to know. Okay, we'll start off with the back side of the worksheet next class. And I think it's about quiz time, right?